Thank you everyone, and a very good morning to all of you. So today our lightning talk is on exploring the world of small language models. It's an interesting topic given that we are hearing a lot of things about LLM but not SLM. I'll quickly introduce myself. My name is Pranita Ghole. I am Associate Manager at Red Hat. I'm also a Python developer, and I'm a learner who is learning the new things in this AI world. And today I'm here to share some of my learnings with you all. So okay, so in today's agenda, we will understand what are the real world use cases where a small language model makes more sense than a large language model. Then we will go to the definition of like what is a small language model, then how does it differ from a large language model, the advantages to use and especially when to use it. And then we'll have some of the examples of the existing small language models. And then lastly, we will also like go through what are the limitations of the small language model. Okay, so this is like an example. Let's say there is a healthcare provider who wants to create a support chatbot for like their use case, as in on the medical data, and that support chatbot, let's assume, has to be used by the hospital faculty and the patients perhaps themselves for any medical related questions. So their use case is specifically that the chatbot needs to be trained on the medical data sets. However, in this case, the chatbot doesn't need to be trained on the entire internet. Like it's not needed for their use case. They would just like to have the information, the medical information in place, and whatever, of course, any patient data or doctor data they would like to see. So this is where a small language model comes into picture, that we only focus on the data or the part which is relevant to us, and like not on everything basically. Okay, so what are small language models? So a small language model is nothing but a smaller version of a large language model. It's basically, like I mentioned, that has more specialized knowledge. It is faster to customize, and it is more efficient to run. So we will see all like why it is so in few minutes. The main differentiator here is a language model with a small number of parameters. I think this is very important, where how a large language and a small language model is getting differentiated by the number of parameters. Let's say we hear any model name, perhaps Llama 8B, Llama 3B, 2B. So what is all this 2B, 3B, 8B? These are nothing but the parameters of that model. So small, okay, so let's first go through in a very layman language what are parameters. I'll start with a small example. Let's say we have to write a model who can give us the price of let's say a house in Brno, and I kind of have just in mind what are the number of rooms that house has, and let's say per room I have a fixed price, and I just say that okay, number of rooms into the price of one room should be the ideal price of the house. But when I talk to my friend, she mentions that that's not only the factor, you should also consider some other factors while guessing the price of a house. And so on, as I talk to more people, I get more inputs from them. Like some would say that you should also consider whether that house has a garden, what is the proximity to the office or to the kids' schools and everything. So all these are basically parameters which will give me more accurate answer, or at least let's say more parameters means more accuracy. Yeah, that's not always the case, but majority of the times. So like this was a small example. I would say that just to explain what are the parameters. Okay. Yeah. So this was just a small example to explain like what are the parameters. But of course, in LLMs, this does translate into the neural networks and then the multiple layers of neural networks. But yeah, the basic idea of like the parameters is the more LLM parameters it has, the more we can say it has a huge amount of, it can guess the things accurately than the one which is trained on lesser parameters. Okay, it is basically, since it's just a smaller version of the LLMs, it is also like designed to understand and generate the text. So, but it's just with a lower computational needs, and that is because it has lower parameters. It's like I mentioned, it's trained on smaller data sets and tailored to very specific industry domains. Now, last point is covering that how can a small language model be built. So it can be built from a LLM as well using a model compression technique. So there are around, like, for example, knowledge distillation. So knowledge distillation is basically a LLM is there, and it will be a teacher-student mode that the small language model will learn from its teacher and will not only try to mimic how the teacher is kind of giving the output, but also like how the teacher is identifying the patterns. So basically we can say it is the distilled version of the large language model. Next is the pruning part. Pruning is basically removing the unnecessary things which a LLM has. For example, in the neural networks which the LLM has, the weights of, since these parameters also has specific weights and biases to them, like for our house example, we can say perhaps if the office area or kids school is near, then the weightage is more than, let's say, a particular parameter, perhaps garden has a lower weightage that time. So pruning is basically removing the unnecessary, I would say, weights from the model so that the size shrinks. And the last is the quantization. Quantization is, we will go for a lesser precision value. Like let's say we want, we will store it in a 8-bit integer thing, and rather than storing it in a 32-bit floating, so that the space and the size of our model shrinks. Okay, so now we will go to like how the comparison between both of them is. Okay, so parameter size. Now there is not a like a straight away limit that, you know, above a particular parameters it is classified as a large language and below it it is a small language. I would say even a few models which are in billions, 1 billion, 2 billion, are still classified as a small language model. So the parameter size is in millions or a few billions, and in LLM of course it is in billions and even trillions with the recent developments going on. Speed of response is faster in a small language model, and the inference output is slower in a LLM. Hardware, that's the good part of SLM is that it can run on the laptops, phones, and the edge devices as well, because it's very lightweight as compared to a LLM. However, for a LLM, we will need GPUs or clusters. Accuracy, when it comes to accuracy and reasoning, a small language model does good on the very domain specific thing, but it will perform poorly, or we can say a very average kind of thing, on a generalized, general queries which it's not been very much trained for. And LLM, since the parameters are high, it's better and advanced even for the general queries. Cost wise, small language models are low, as you know, they can be run on your laptops itself or any edge devices. You would not like have to have a GPU with them. Even the training process for them doesn't take a lot of time, and the training process is also cheaper for them. And the cost is of course high because of the GPU infrastructure, the amount of time in training and everything. Privacy control in a small language model is high because we can own the infrastructure. Like we can develop the infrastructure, we can own it. But for a large language model, we have to have a cloud provider and then deploy it there, or some external this thing. Energy use, like I mentioned, since the training and is easy, it's energy efficient, and the LLMs are energy hungry. Custom training, it's easier to fine tune with small data set, and this one needs massive data and compute power. Just quickly proceed. So yeah, the advantages of small language models are pretty much same what we went through. The accessibility part, especially because the developers can also explore themselves, because they can run that model on their own laptops and start exploring and working. It's lesser computational requirements, lower latency and the effective performance, greater privacy. So the fields, especially where privacy is of essence, let's say any medical or legal fields, it's a perfect use case for them. Reduced cost, of course, when you are in a cost restrained environment, or when you have a cost restraint, you should definitely go for a SLM, and it's more environmentally sustainable. Okay, when to use a small language model? Some of the things like we already discussed, but just a quick repetition. When you are low on, when you are low on resources, or you have to go for a on-device AI, as in you would need it on a mobile phone, or you need it on, let's say, any edge device where it might not have a lot of resources. That's a good use case for small language model. Fast response and low latency, narrow domain-specific tasks, privacy-sensitive applications, offline requirements, and sixth is the rapid iteration and fine-tuning. So let's say if you are in a prototyping phase of something, that's a good way to use small language models, as the iterations or the testing, you can do it faster. And of course, in cost-constrained scenarios. So these are the few examples of small language model. There are, of course, many. We have Distilbert, we have Tiny Llama, Granite 3, and this is by Microsoft, Phi. And like you can see, this is an example that while we are reducing the size, like 40% smaller, but it's 60% faster, and also like it's retaining 97% of the capability of its large language model. I think that's a good example how small language models are offering the advantages without actually compromising a lot on the quality. Okay, let's go through the limitations. So limitations, of course, are it has a narrow scope of knowledge and a very limited generalization, because it's trained on lower parameters, less parameters, and it can answer well your domain-specific questions. But if you try to use it for any general use case, it will not give you good results. Decreased performance on complex tasks. So example, any multi-step logic thing, or any use case where a lot of, let's say, creative writing or all those things, SLM won't be able to do well as compared to a LLM. So yeah, for the complicated tasks, LLM is a better choice. And these, like the risks of the general AI, which we have bias and hallucinations, they are of course there in the small language models as well. But it's just that these biases could be amplified since we are training on smaller data sets, and so we have to be a little careful of the bias and the hallucination part as well. So yeah, these are like the limitations. Okay. Any questions, anyone? So small language model, okay, so the question is how to build a small language model. So a small language model can be built like taking a LLM as a base, and then like we can go through these we can go through these model compression techniques, and like it's just a few, but like there are low key factorization, other methods as well, which we can use for like small language model. Okay. So for example, let's say there is a translation language model, which a large language model is, let's say, trained on a lot of languages. If we want to build a small language model out of that, then we can like select the specific languages and only train it on those, let's say, 2 or 3 languages, and like eliminate the rest. Yeah.